Every generation has figures who look at the horizon and predict what comes next. A rare few go a step further. They promise to build it. For millions of people, Elon Musk represents the bridge between current technology and future possibilities. He maintains this perception through the public activity of his companies and a stream of product reveals, social media updates, and lengthy interviews. When speaking to packed rooms of journalists and followers, the underlying message remains consistent. The technologies of science fiction are only a few years away. Over time, however, a fracture has appeared in that narrative. A growing number of observers are looking past the initial announcements and tracking the actual results. They point to a specific, repeating pattern. A project with massive implications is announced with a highly aggressive timeline, followed by years of push deadlines and unmet expectations. Which brings us to a question hanging over his empire today. Is Elon Musk our preeminent innovator, or has he simply mastered selling the future? To answer that, and to understand why these current projects face such severe delays, we have to look back at the historical track record that gave him the platform to make these promises. 2 decades ago, the automotive and aerospace sectors were characterized by slow movement and absolute dominance by entrenched legacy players. The economic barriers to building electric vehicles were immense. Battery components were prohibitively expensive, and physical charging networks to keep them running barely existed. Major automakers looked at those costs and largely abandoned the concept. That hesitation left a vacuum for a disruptor willing to absorb years of heavy losses. Musk placed a massive bet on Tesla, and the company eventually navigated those early bottlenecks. They scaled up physical manufacturing lines, proving that electric cars could be commercially viable on a global scale. The skepticism he faced in aerospace was even more intense. Building a private spaceflight company was widely considered an unrealistic path, primarily because rockets were designed to be thrown away after a single launch. SpaceX rewrote the economics of the aerospace industry by developing reusable rocket technology against extreme odds. They successfully landed and reused orbital-class boosters, a feat experts previously dismissed. Achieving 2 feats historically labeled as impossible secured a level of public trust that shifted how financial markets calculate the odds of his future success. That track record transformed Musk's personal reputation into a powerful financial tool. His standing alone can move capital faster than almost any traditional metric. When he announces a new endeavor, the reaction is immediate. Investors allocate funds, and customers place deposits, fueled by memories of rockets landing and electric cars reaching the mass market. This chart illustrates the hidden cost of that credibility. The lower line shows realistic engineering progress, while public expectation rises on a much steeper trajectory. When physical reality falls short of these expectations, progress stalls in this gap, which critics dismiss as hype. This creates a unique trap for his companies. Every upcoming product is aggressively measured against his past successes, bypassing standard grace periods most engineering firms are granted. And the roster of projects operating under this intense pressure is massive. It includes the rapid deployment of global satellite internet, advanced artificial intelligence, and as we see taking shape here, highly complex humanoid robotics. Taking on multiple engineering challenges at this scale guarantees severe bottlenecks. It creates a permanent dilemma where significant engineering achievements are framed as failures simply because they were late. Today, the most anticipated promise-testing public trust is happening on public roads. Tesla's pursuit of autonomous driving is arguably the most scrutinized project in the company's history. The stated goal has remained consistent for years: to deliver vehicles that can safely navigate anywhere, under any condition, with absolutely no human intervention. The reality is that building a completely reliable robotic system to navigate the unpredictable variables of the physical world is proving to be one of the most difficult engineering problems ever attempted. Tesla has advanced its driver assistance software, but closing the final gap, moving from human supervision to a system that can be entirely trusted on its own, remains a massive obstacle for the entire industry. This chart compares how different types of products evolve. The top timeline shows traditional product iterations, predictable, evenly spaced, and heavily scheduled. The bottom timeline shows the reality of significant shifts in technology, which are erratic and rarely fit into a quarterly earnings report. Some breakthroughs take months. Others require decades of trial and error. When you attempt multiple generational breakthroughs simultaneously, chaos and delays are an inherent part of the process. The debate over Elon Musk's timelines isn't going away. This ongoing push for autonomy is the highest stakes demonstration of the promise machine to date, leaving us to watch and see if the autonomous future finally arrives, or if it remains the biggest unfulfilled project in his portfolio.